introduction. And this is quite exciting. I'm sorry I can't be there in person, but I have 20 minutes to explain to you quite a big concept coming forward. And I think some of you have attended some of Robert's and Sebastian's workshops during the past day and so forth, and probably know most of us already. So just a quick little disclaimer before I start. Everything's still in flux and moving forward at a super fast pace. This is the team, as mentioned. I need to just add to this, we're all from industry, as well as the fact that none of us are on the same locations. Well, Robert and Sebastian are close by, but we basically work live on real projects from London all the way to San Francisco and Seattle. So we prove really what we do, and we're trying to tell you to do with Omniverse and USD as we go forward. Also, probably not necessary to mention, but 3D workflows are in all industries and all aspects. And we've seen some development and progression very much so in other industries that we are trying to infer into architecture and construction, and likewise reverse that into other industries. So nothing stops us from using a SketchUp or Revit model to eventually go train an autonomous vehicle. And I think we need to start understanding that this is the way forward in industry and the way forward we're going to be designing and building city infrastructures. So what is Omniverse? So I'm going to show you a quick little video. It's about 2 minutes, which is on our digital twin, which relates to our industry very much. And I think it covers engineering and construction and architecture in this little concise little clip that I'm going to show you quickly. And I hope you can hear the sound. Well, as you notice, Omniverse is very much used in the M&E as well with that dramatic music. So I think we need to start with USD, which is a universal scene description, and it's developed by Pixar quite a few years ago already, 12, 15 years ago already, and very much used in quite a few industries before we even started entering this into the AEC industry. It's open and it's extendable, and it's really there to help facilitate build complex 3D worlds. Now, what we're doing on top of USD and what we help USD develop as, because USD is open and we don't own it, is to integrate all the applications that we typically use as designers. And we're not saying that you must use USD as a design application. We're saying that you must keep using your applications best suited for your needs and synchronize everything in this agnostic space, this USD world, so that others can participate and we can start growing buildings and develop buildings beyond the need of design into operations and simulations and the likes. As you can see, a fair bit of familiar names, and we have many, many connectors into USD. USD is open format. It was open formatted in 2016. And Nvidia also developed MDL, materials definition language, that we also made open source. And the combination of these two really allow a geometry data set that has the ability to have not only visual materials assigned to it, but full physical properties to it. So you can really start simulating what you are building and what you are constructing and engineering in real world terms, but in a virtual space. And then, of course, we're developing Omniverse to sit as a sort of eye or as an enabler to USD and to MDL, and as well as to all the other microservices that Nvidia and all the other companies are developing. And Omniverse allows this interaction of USD with applications, maybe your own applications between each other and so forth, or your colleagues or partners in a building, or as we do as a team with projects across the globe, right? We work with singular data sources on cloud servers from anywhere in the world where we want to be. Now, this is a very familiar one, and you guys are going to probably be bored by this little picture, but this is the issue we still have to this day in the industry, right? I'm in application 1, somebody else in application 2, etc., etc. You know what this is about. And we have very good ways and developed very good ways of how to interoperate between these applications, but they are still restrictive and limited, and they are still only built within our industry with our needs. And I think we need to start looking beyond this. Now, we add a level of complexity to this where I'm in application 1 because I'm prescribed to use application 1, and it has a function that I can use in application 1, but the function application 4 is so much better. And I prefer to use the function application 4 because it is better for the need that I have. But I cannot get 1 to 4, or if I do, there's data loss and integrity loss between it, and then I have to go back again. That's my one option. Or the other option is make do with what is in application 1, where that function is not the main focus of that software, but I have to then compute that function inside that software. Right, and this is limiting. This is not where we see the future is going. The future is basically where we want to be using the applications that is best suited for what we need to do to deliver the cities and the buildings that we are designing. So that's why we are talking about a complete agnostic open format, USD, and Omniverse allowing this enablement of this, where we are saying, well, now you can pick the software that you want to use, collaborate with that in USD, and start building multi simulations or worlds of your buildings. And then add this layer of compute on top of this, because this is the big differentiator between USD and the other really well-known and very, very robust collaboration platforms and databases that's out there, is that we have the ability to compute geometry and visualization as well as data machine learning on top of a single data source coming from multi-applications. So we're not forcing you to use a application, we're telling you to use your best application that you're comfortable with and that can do the task, and then allow global or server level compute on that and bring the experience back to you as a visualization. Relate to this as a way of working with InDesign or with probably with HTML or the likes, where we don't actually care where the source is coming from, and something might be completely different to something else as a source represented in a single page or in a single format that you can actually read or experience as an evaluator or reviewer as such. And I've had a lot of a hard time with telling people that all designers shouldn't need to code, and even my colleagues probably don't agree with me with that. But you can agree that many times, or probably all the time, as you interview someone for a serious design position in your company, you look at their software capabilities. So you're almost putting them and their software technology skills above their design skills. And then you have the really this differentiation between a designer that has to grapple with software and software updates the whole time, and a computational expert that's sitting on the other side that they have to interface with and work with, and takes probably time to go and compute something or set something up and come back and forth between this. And what we are hoping is going to happen, and this is with the democratization of technology and this opening of all these sub-functions that are making it more available to people, is that we're going to have a designer that picks the interface that they want to deal with. If the designer wants to use Rhino or SketchUp or Revit or Creo or CATIA or whatever it is they want to use, a pen and a pencil, they have the ability to use that interface to do the function and the task they want to do, and then allow compute and simulation to happen as a step away, and have this experience fed back to them. Because as I mentioned earlier, the experience is through visual geometry and data experience. So we can actually pick how we want to have that respond to us, and how we can see our design decisions in real time displayed back to us, be that VR, AR, web, a browser, however you want to be doing it, right? And I think this is the cycle that we are working on very hard to get in real time globally. And I'll show you some examples of where we are with that right now. This is just a brief slide on how Omniverse sits, and I don't want to lock down on this because I think there's a lot more to talk about. In the center, we have Nucleus, which is the data server as such. It's also a tracking server, so you can actually go back in variations back of files that you have entered. So it manages all your data and your files for you. And then we have Omniverse Create, which is really the creator or the advanced user's interface or entry into Nucleus. That's where you'll be sitting in Rhino and click a button and you'll live sync geometry back to the server that somebody else in Unreal Engine, for example, can view or see. And then on the right-hand side, we have Omniverse View that is mainly for review, markups. We do real-time markups, measurements, do storyboarding through it and the likes. And that's very much for project managers and reviews of what is happening on a project and to be able to feed back to the designers to do changes and the likes. There's a lot more on this. Of course, I have to, just one slide I want to show you on this because I want to get into the actual application side of this. Please ask us more. We're happy to go into the details of how this is deployed and built. Further, as I mentioned, there's an incredible amount of apps, connectors that we have that can write an interface with USD that you can view geometry inside Omniverse of. This is related to applications itself, as well as to data and libraries, materials, and the likes. And I think one very important thing to note as well that is that Omniverse is not a software, it's not a piece of application. It's actually a framework or platform that allows you to build and extend upon. And some of you may have attended some of the sessions yesterday, as well as from some of our colleagues at Heatherwick, where you have an ability to write your own extensions or use some of the thousands of extensions already developed out there. When we talk about functions, this is exactly where we come to it in a real sort of manner, where we can go and pick a little specific function that is really well done and written for what we want to do without the overload of all the other software that sits around it, right? Because we have a format, a USD file or assembly of files that we can perform compute on top of. So here's a typical scenario, just as very entry level of how USD and Omniverse works. We have a designer here. She's doing a lobby design. She's just written it out to Omniverse. She's opening it up. The standard renderer at the lowest level is a ray tracer, just so you know. And now she's adding more USD files as sub-layers to her lobby design. Now that means that she can structure the layers in terms of priority, and she can structure functions on top of each other in terms of priority, like you would do with Photoshop layers in a similar manner. She's adding some sub-USDs and she's tweaking some materials on this until she's happy with it, right? And she will now go ahead and say, well, now we have this assembly of 3 or 4 files from different formats or libraries, and we're going to go and assemble the ground floor. So she's taking that assembly of files, placing it down, and then including from other designers assemblies of their files to make up the ground floor. And those could be done in any application, Blender, SketchUp, Revit, however you want to choose it, right? It could be from a consultant, it could be from your own team, a team across the waters, or however the case might be. But the great thing about this is she's seeing her design along with all the other designs. Now, we all know Grasshopper. We know that it's a very, very good computational platform. So what we're using for Grasshopper in this instance is to determine the unit mixes for apartment to answer a brief. Another designer is doing Grasshopper functions to design facade variations, so options of facade. And here we have a Revit model with multi other applications making up this scene that you see here, and we're loading options of the Grasshopper that we have developed. So we have 6 facade options, right? And one of the functions of USD is to have variants, and we have the ability to live swap. This is real time variants from Grasshopper. And if the designer of the facade does a change and we do a live swap, we will see that change happen in real time. Now take that a step further, right? And now we actually have a variant per floor, as well as for the facades, as well as for the structure of the building. And what we have here is a building configurator, right? Running live off the DCC and configured live in front of us to be able to swap our data. And because we have that, and we have the ability to extend it, Robert, one of my colleagues, have written this counter. So now we have a configurator where we can live swap apartment mixes in relation to the facades and responding to the facades and the structure that we were selecting, and have the mixes counts happening in real time. So we can sit with the client and going, well, do you prefer this facade or that facade? Do you prefer this layout of unit or that layout? What does the brief require in terms of the unit mixes that we need? Can we start mixing that live as a configuration like you do with a car until we meet the brief and then instruct the designers to do the tweaks and changes of the backend? But I'll pause that a little bit, go think about that. It's quite powerful. Furthermore, we here in Rhino, and I'm using a compute function here to do my counts and my positions of my units, of my apartment units. I do not want to overload of furniture or plants or any vegetation, anything to do renderings, right? So what I'm doing here is I'm doing a swap of assets as I go from Rhino and Grasshopper into Omniverse. The interior is done inside SketchUp because the designer preferred to use SketchUp for the specific interiors of this. I'm not an interior designer, I'm a computational designer, but the interior designer is doing all these interiors. And what I'm doing, I'm live swapping the Rhino model with a SketchUp model, right? Which basically means I'm controlling SketchUp model placements with Grasshopper. I feel like I need to pause on that one again as well. So there I have the whole building swapped out, right? And I can continue to compute the placements of the units on the left until it makes up the numbers, while the interior designer is continuing to do her work on the interior and tweaking it and adjusting it, getting it ready for client reviews or marketing material or whatever the case might be, right? Again, the applications are feeding live into the USDs while I'm configuring the USDs in the way I want to put the building together. Now, here's a further level where we go and say, well, I'm running Grasshopper and Rhino at the moment. I'm looking at a shading part on the left-hand side of the building, right? My colleague in New York, I'm in London. My colleague in New York has that model of mine open with all the other models that make up that realistic scene, right? I don't need to see all that. It's not my concern. My concern is to shade the side of the building and to use the computational scripts and feed that geometry right up to the other side. Now, in New York, my colleague is actually looking at this model in real time while I'm adjusting it from London, right? So when I do a change in geometry, he sees that in real time. But he's more concerned, he's not concerned about the computation because that's not his job. He's concerned about what the building's look and overall feel will be like. So he's starting to apply overs on top of my geometry to change materials that don't affect my geometry at all or my file or anything that I'm doing. He can go and delete those deltas or we can go and merge them and replace them. So all of a sudden, my colleague in New York can go and do 3 or 4 material variations on top of the geometry that I'm doing, live feeding the geometry I'm doing on this in a sort of non-destructive way forward. And that's another great thing about USD and how it actually operates. And we're talking about the structure and layer of USD here. Of course, we have advanced render capabilities as well. We have path traces, we have iRay, and therefore we have a true light calculation. So this is that interior scene that you can see. The lights here, incidentally, are placed from Grasshopper script, and the models come from SketchUp and Rhino, all combined together. And we have a light simulation with multi-files together. We don't need to get it into one software to do that. Now, my colleague in New York decided to have a review with my colleague in San Francisco. So on the left, on the big screen, is my colleague in New York doing the changeovers of the variations of the facade, while my colleague in San Francisco is streaming that live to a tablet. So he's placed the model in front of him as an AR model, looking through a tablet and walking around the model in a very intuitive manner. Remember when we talk about the experience of what we compute and how we can interface with that? In this case, we're picking a tablet as an AR device. There's no optimization happening here. If I do a change in Grasshopper, that'll reflect in the New York model that's being controlled, as well as the model that's being streamed to San Francisco, right? So there's no decimation or optimization or baking or anything, right? And that allows the reviewer or the person that wants to make the decisions to have a sort of very intuitive interface or experience of the building. We keep saying experience here, to understand and to experience the changes and the effect of the changes and how they feel about that and what is the best solutions that they need to pick or further develop and take on. Now, bear in mind, model generated in London, controlled through New York, reviewed through a tablet in AR in San Francisco in real time. Right. Of course, analysis is quite important. So we're running a very simplified generative script with daylight hours on the adjacent plots, and we're feeding that animation from Grasshopper directly into Omniverse. So we can kind of scrub Omniverse and look at the various building shapes and orientations and what the performance of those are. We can, of course, also go and overlay all the diagrammatic data on a realistic model. So we're not looking at this as an Arctic or a pure simplified render. We can actually see it as a full experience model that we can again stream or do whatever we want to be doing with it, as well as some of the advanced compute functions that we can lay on top of that, like the CFD and furthermore. And I'll go a little bit into that because it is a more complex interface. So when we talk about compute and moving compute slightly away, we've been developing an interface with a cloud-based compute application called SimScale. So we can actually take multi-applications, feed it into a USD or a USD assembly, push that to the cloud, have someone in the workbench there do advanced CFD compute and feed it back into Omniverse. What we're doing here is we're bypassing that last process because we want to do some more post-processing on the CFD in ParaView, and we have a live ParaView connector. So as the engineer is updating the review and the methods of visualizing the CFD, so is the designer simply seeing and feeding that data into this live model. Now, we're not feeding the CFD into a block or a simplified model here. We're feeding the CFD into a full detailed model made up of City Engine, of Revit models, of Grasshopper models, Rhino, SketchUp models, and the like. So we're getting the full experience of what this wind is actually doing to our detailed design. So we can start making decisions about where we should have air intakes for natural ventilation, where we should have maybe some energy capturing through wind, or where we should do some diffusion or banking of wind and so forth to allow that restaurant outdoor area to experience the waterfront in this case in a better way. And again, this is the point where we take scientific and engineering data and we're trying to make it an experience for those who actually need to understand and make decisions in the building. And it comes down to the point of we want to feed, and we are working hard to feed any application in to bring it all together in one synchronous space so that the designers and the reviewers and the stakeholders and the operators can actually understand the impact of their decisions and what they're doing with their buildings. Just a very quick note here. Some of the applications we have bidirectionality, and I'm running slightly over time here. This is just showing you that you can actually use 3ds Max and Omniverse Create, and you can pick any application and work in any one of them, and they'll feed across, right? And then just to cap up here, this is just showing you a handful of the applications that we've used on that project. And we're showing you those with various versions of Create as well, where the users are using those applications singularly or collectively together as they want to. But it really brings down that fact that you choose the application that is best suited for your preference and for your need and for your tasks, and then put it into this agnostic format, this open format for everybody to collaborate and compute upon. Again, just a quick little list of applications we've actively used in this project. There's an incredible amount of information, out there. Please go and dig around on it. This is my email address. Maybe Robert and Sebastian, if you're in the audience, maybe just raise your hand so people can reach out to you. Two of my colleagues from the team members are there in person, and go and discuss, grab a coffee with them, go discuss further with them as well. And please go to the Omniverse AECO page for any more information. I know there was a mouthful. There's a lot I try to get across here. But yeah, thank you.